cyclone. As a cyclone removes particulates by causing the dirty air stream to flow in a spiral path inside a cylindrical chamber. Dirty air enters the chamber from a tangential direction at the outer wall of the device, forming a vortex as it swirls within the chamber. The larger particulates, because of their great inertia, move outward and are forced against the chamber wall. Slowed by friction with the wall surface, they then slide down the wall into a conical dust hopper at the bottom of the cyclone. The clean air swirls upward in a narrow spiral through an inner cylinder and emerges from an outlet at the top. Accumulated particulate dust is periodically removed from the hopper for disposal. Cyclones are best at removing relatively coarse particulates. They can routinely achieve efficiencies of 90% for particles larger than about 20 micrometers, μm, 20 millionths of a meter. By themselves, however, cyclones are not sufficient to meet stringent air quality standards. They are typically used as pre-cleaners and are followed by more efficient air cleaning equipment such as electrostatic precipitators and baghouses, described below. Electrostatic precipitator. Electrostatic precipitator. Electrostatic precipitator, a common particle collection device at fossil fuel power generating stations. Electrostatic precipitation is a commonly used method for removing fine particulates from air streams. In an electrostatic precipitator, particles suspended in the airstream are given an electric charge as they enter the unit, and are then removed by the influence of an electric field. The precipitation unit comprises baffles for distributing airflow, discharge and collection electrodes, a dust cleanout system, and collection hoppers. A high voltage of direct current, DC as much as 10 volts, is applied to the discharge electrodes to charge the particles, which then are attracted to oppositely charged collection electrodes on which they become trapped. In a TPU unit, the collection electrodes comprise a group of large rectangular metal plates suspended vertically and parallel to each other inside a box-like structure. There are often hundreds of plates having a combined surface area of tens of thousands of square meters. Rows of discharge electrode wires hang between the collection plates. The wires are given a negative electric charge, whereas the plates are grounded and thus become positively charged. Particles that stick to the collection plates are removed periodically when the plates are shaken or wrapped. Wrapping is a mechanical technique for separating the trapped particles from the plates, which typically become covered with a 6mm, 0.2-inch layer of dust. The wrappers are either of the impulse, single blow, or vibrating type. The dislodged particles are collected in a hopper at the bottom of the unit and removed for disposal. An electrostatic precipitator can remove particulates as small as UM with an efficiency exceeding 99%. The effectiveness of electrostatic precipitators in removing fly ash from the combustion gases of fossil fuel furnaces accounts for their high frequency of use at power stations.